Hi guys, welcome to Not So Nerdy channel. Today we are going to discuss what a sliding window is because the next questions will be based on this topic. So let's go. So what is a sliding window? The idea behind the sliding window is to create a window of a fixed size. It can be variable and I'll discuss about it in the next slides. So it's let's say it's a fixed size and slide it over the array or sequence, processing each sub-array or subsequence that falls within the window. And this technique is useful in problems where we need to maintain a sub-array or subsequence of fixed size and slide it over the array to find the optimal solution. So here's a short example. We have suppose 1, 2, 6, 8, 9, and 10. So the current sum of these three elements is 16. Now we shift our sliding window. We slide the window basically to the next index and leave the first index behind. So now we get current sum equal to the previous sum which was there, that minus 2 plus 9, the new element that got added. Okay. So that's the basic usage of sliding window. Now we don't have like a specific syntax. We simply, depending on the problem, we will use it. Now there are three main steps. One is initializing the window, sliding the window, and updating the solution. So initializing involves defining the initial window size, initializing any variables needed according to a requirement to keep track of the window's state. And then we slide the window. This involves iterating over the array or sequence and updating the window's state by adding or removing elements according to whatever conditions we want. We slide the window and then finally we update the solution. If it's optimal, we get our answer. If not, then again we slide to the next. Okay. Okay. So here's a short example for you to understand. Suppose here we have a function maxsum subarray with array and k as the number of elements that should be present in the window. So here k is 3 because there are 3 elements that we are keeping in our window right now. Now the window sum will be sum of the arrays. We are using slicing here and we are slicing it till the kth index. So the last this k is won't be counted, so we will have till the first element till the k minus 1th element, k minus 1th index. So since k is 3 here, we'll go from 0, 1 until 2. That will give us a sum of 9. And that value will get stored in window sum. And now we will initialize our max sum with the window sum. Then we will start a loop for I in range k till length of array. So here k is 3, meaning from here we will start our loop. Okay, so this will be our I. Now here the window sum, as we saw in our previous example, we saw that the current sum gets updated where the 2 gets removed and the new element gets added. So similarly, for this, 1 will get removed and 8 will get added. So for that, we are using this formula, window sum equal to the initial window sum which we had plus array I, the ith, the value present on the ith index, minus the value present on the I minus kth index. So I here is 3, k here is 3. So 3 minus 3 gives us 0. And at 0th index, we get our value 1, and which we are subtracting from this. And finally, we compare the max value between max sum and window sum and store it in max sum until it reaches the end, and we get our maximum sum and return the maximum sum. Okay. So that's the basic working of sliding window. We will see more examples. This obviously helps in time complexity in reducing it. especially when dealing with arrays or sequences. Reason is that the sliding window technique allows us to perform computations on sub-arrays or subsequences of a fixed size without having to process each element individually. Um, So we do not have to we don't have to process each element individually. We can use the sub array technique to reduce the time complexity. Like in the previous question, if we didn't use this, our time complexity would have been O N K, and it got reduced to N for finding the maximum sub array sum of length K. Okay. So the types and uses. There are two types of sliding windows. One is the fixed one, which we already saw. It moves one step at a time until the end of the array or sequence is reached. Next is the variable sum windows. And we have used this concept in our previous questions based on two pointers. Because two pointers is basically a subset of sliding windows. It's a variable sliding window because the sizes can vary. We had a left side and the right side, and we used to adjust it according to our needs. So here, in the similar manner for variable sliding window, they have a variable size, and the size of the window changes as we move along the array or sequence. And again, this type of sliding window is useful when we are looking for sub arrays or subsequences that satisfy the requirement and get a desired output. And similarly, yeah, so have a dynamic usually has two pointers that move in the same direction, and windows expand and shrinks depending on the subset we are looking for. So there are basically two types. Now, usage. So we can use it in a variety of problems that include string matching, substring search, maximum subarray problems like we saw in the previous example, and many more. Okay. Yeah. So that was a short introduction to sliding window, and we'll get a more detailed understanding when we'll solve the upcoming questions from NeetCode 150. And feel free to ask your doubts, ping me on LinkedIn or Instagram. And yeah, thank you so much.